Next speaker is Martin Sukel. Martin is AI lead of the City of Amsterdam, and his talk will be on the subject of urban AI in Amsterdam. Welcome, Martin.
Yes, thank you for the introduction. So my name is Maarten. I'm from Amsterdam. I'm working for the city as AI lead, which is very interesting. And I'm also a PhD researcher at the University of Amsterdam, also in the same field. So today I will talk to you about all the AI projects we do in Amsterdam, and I hope you find it very interesting. So I will start briefly with what we call, Amsterdam Intelligence, what we mean with that. Then I go quickly into the AI agenda of the city. And afterwards, I will really fast try to explain some basic AI. And then afterwards, I will dive into a lot of projects. So show you a lot of examples about what it actually is. So this is a nice quote from our deputy mayor. Actually, you could summarize it as, we think AI is very cool and we really want to invest in it. But at the same time, we also want to be wary because it's a technology that's going to have, effects in all parts of society. And we want to make sure that actually these are beneficial effects and not negative effects. And so basically that means that every day me and my team, we're working on using state-of-the-art AI and actually applying that to the problems of tomorrow and see if we can come up with solutions with this technique. So we don't do this alone in Amsterdam. We work together with the different cities in the Netherlands, with knowledge institutions, but also with international organizations to make sure that we can actually understand this new technology. Because the research in AI is going so fast, we really need to collaborate with the academics. Because they're writing so many papers, I think it's impossible for one person to read all. It will be impossible for 100 people to read them all. Maybe AI could help. So briefly, the Amsterdam AI agenda. One of the core points is we actually want to make the technology work for the people. So instead of using it to get people to click on ads online, as a certain American tech company really likes to do, we want to make sure that it works for the citizens of the city. I think a theme this conference has been mentioned before. So I'm glad we agree on that. Also, we want to stimulate the ecosystem in Amsterdam. As I said, we need a lot of people to keep up to date with this research and actually start using it for society. Another core point is the digital rights. We want to increase equality in the city using AI, where normally it might actually achieve the opposite. So that's one of the things that you will also see in the examples that we try to achieve. And another point is we want to make the data available. So not just the open data of the city, but also the data that is used for training the models and the algorithms. We want to share that so researchers can use it and other cities can learn from our mistakes and actually use our non-mistakes. So I will briefly go into AI. You can see here, I think AI is one of the, there's a lot of buzzwords related to it, a lot of different techniques, and it's a lot for a human to see. So these are some of them. I will now describe I will start here. This is, for example, pose estimation, where you can turn an image, basically just a 2D image, and extract the pose of a person. So that's one use of it. This is another example. During COVID, we made this truck where on the screen you could see if you were keeping enough distance. So actually in the truck there was a small computer just doing the calculations. So it's sort of like a digital mirror that we use to communicate about social distancing. This was like during one of the peaks where people were shopping in the December months. So maybe this year we will use it again, like a new way to show people how to keep distance. So that's also how you can use AI. And this is, for example, a deepfake. So I'm not sure if you recognize which one is me, but the other one is Tom Cruise. So maybe not very useful for cities, but I think it's a very interesting technique. So I just wanted to show you that. And later I will go into all the city things, so transportation and garbage and crowdiness. But because I don't always like talking about garbage, I'm now using a tree as an example to see how it works. So what's normally the way, I would say, programmers used to, detect a tree, for example, in an image. They would describe that it has green leaves, a brown trunk, like of a small width, but that has its limitations. So for example, these are also trees. Like, well, the trunk is a bit different. The palm tree doesn't really have leaves, not sure if you can say it like that, but at least it will be hard to detect. And when you end up with trees like this that have no leaves or different colors, then it will also not work. So the thing with machine learning is actually that you will give it examples instead of describing what you see. So you will say, for a lot of pictures, this is a tree, this is a tree, this is a tree, and then you give it a lot of examples of, well, things that are not tree, but that might look similar. And that's how you can learn. And because I will be discussing computer vision a lot, here's some examples of like the different ways it can be used, which I think is very important that it's already, this subfield of AI, computer vision is already quite broad. So you have the image classification where you're doing like the whole image, so you would say this is a dog. You have instance segmentation where for every pixel you're saying the class, so for every pixel you know it's a dog. You have object detection where you're actually locating the object on the image. You have counting, so you say this is one dog. And then you have facial recognition, actually something we do not want to use in Amsterdam because we think there's too much risk for privacy. But then you would say, okay, this dog on the image is called Rakker. It's a very cute dog. So now I will dive into the urban AI projects we're doing. It's not all of them, but I had to make a selection. But if you want to learn more, we also, at the end, I will share a website where we have all the projects listed. So first I will dive into customer service requests. It's a system we've been using for some years now to actually route requests from citizens to the right department. So we have 300,000 requests every year and rising, and about 80 departments where they have to end up. So actually it's like a, well, you could say a smart interface where people can just describe their problem and it will be routed to the right department. And afterwards I will go into object detection kit. It's a system where we're actually using cameras on the streets to scan for issues. For example, where is there garbage or something broken. Then I will briefly mention a project about crowd counting, which is available open source, so maybe, I think very interesting for most of you working in crowds or whatever. And finally, I will dive into a new project we're doing where we're actually analyzing 3D point clouds, which I think for cities is going to be really changing how we work with data and how we collect our data. So to start with the service request, as I said, there's more than 300,000, it's wrong. There's 300,000 requests. Sometimes citizens make more than one, but it's a lot. Some days it's more than 1,000 a day. We actually want to make sure that we get there as fast as possible, because when somebody makes a request about something being broken, we want to fix it quickly. About a dangerous situation, we want to fix it. And then you also have, for example, nuisance complaints. And well, if the system is not fast enough and somebody makes a complaint on Friday evening, like, hey, the bar next door is being too loud, or for whatever people are doing, they always do very weird things, especially in Amsterdam. And they get a message on Monday with, we went to the location and nothing was found. Yeah, you can understand that's not a very effective way of working, and also not making people happier and the city a more nice place to live. So what we do here is actually, based on past examples, of course, we had millions of these requests already with where they should end up, and we could see when people were happy with the solution. So we used that to train a model doing text classification. So when somebody says it's nice weather, but there's a lot of boats coming by with loud music, actually it will use the past examples to learn that this is about, well, a disturbance on the water. And so this is a system where a report is made, also by phone or on the website. It's classified and sent to the right department. It's a completely open source system, so not just the machine learning part, but also the whole system behind it, because that's crucial to have to actually use machine learning or AI. It has to be implemented into systems that are already there. So you can find more information on it on the website signalen.org, which means signals for everybody not speaking Dutch. So using a system like that seems nice, because, well, you can help people more efficiently, and that's always good. However, there's something with machine learning that it enhances the world around us. So for example, if somebody is writing a report in Dutch, it will probably recognize it really well, because 95% of the reports we get are in Dutch. But as I showed with the 3 examples, the more examples you have, the better it will work. So what if somebody writes a report in English? This also happens. It will work for like the bigger categories that we have enough examples, but it won't work well for things that are less occurring. So mostly the things related to humans doing weird things, those are always tricky because that's really diverse. Garbage tend to be described in the same way. That's actually, it will more likely make a mistake, for example, or be less confident, which would actually cause the system to not recognize it correctly, maybe send it to the wrong department. So you have to be aware of that it will have effects like this. And also, if somebody is, not that comfortable with using a keyboard, or maybe doesn't even know how to go to a website or how to contact us at all. So that's also an issue. That's a bit past the machine learning part. It will maybe detect it even worse. So what you get here is a system that works well for people that know how to write nice and clear Dutch, and it will work less well if your language capabilities might be a little different. So, of course, to fix this, we made sure that when there's doubt in the model, we actually have humans look at it as quickly as possible to route it. But I think it's an interesting example of when using these techniques that there are effects that you might not be aware of. And because, we thought there's also, like with these requests, there's a difference. So in some areas, there will be more people reporting than in others. And we think the city should be, cleaned, maintained equally, because it's like a base for how you live. And then you see these numbers, like the number of cameras worldwide, increasing very rapidly. Like next year, they expect there to be 44 billion of them. My phone, for example, I think has 6 cameras, so I do trust these statistics, especially how cheap they are becoming. And as I showed before, like with computer vision, you can now analyze these images. So this is an example of a street in Amsterdam with a model that's not even optimized for this situation, and it's already really good at distinguishing different elements on the street. So getting information from images is becoming easier and easier. So we figured, what if we, instead of waiting for our citizens to come to us, like, hey, there's an issue here, we actually somehow use this computer vision to go hit the streets and see what's going on. So that's why we trained the model. This is already an older version, but I think it shows nicely. That's capable of detecting different types of garbage, or if there's a construction going on, or if there's the bollard that might be run over. So this system, I think we did some time ago to see actually if this could work. And we think it can be a success. So the idea is that we have a lot of trucks already driving around the city, trucks or vehicles. So we will actually mount a really simple device you all know, like a smartphone on the dashboard. And that's actually used for capturing the images, because as I showed before, to make this model, we need images of the city. They will drive around, and the moment something is detected, we will use that as like a data point. Hey, there's garbage here, so that needs to be collected. So as I said, the current setup we're using is just default cheap smartphones. I think they're 200 euros each to collect these images. We also have, for example, the more expensive 360 degrees cameras with high resolution. But we use that to capture the city a few times a year. And the idea of this project is, because the city is such a dynamic place, we actually want to scan it multiple times a day. So we were thinking we need cheaper hardware so we can scale up on a large geographical scale. So what's also nice is we can also, for example, detect furniture or materials. I always like the example of a mattress. If you know exactly where mattresses are, you can go collect them separately and recycle them, and they're actually worth money. They're quite a lot of money because the resources in them are reusable. But if you cannot find them in time and it will rain, and somebody will pick it up and throw it in the furnace, well, that's a less optimal situation than the other one I described. So, but for making these models, we need a lot of images, and we need to annotate these images. You might all know that when AI, it's mostly using data annotated by humans. So we right now have a large collection of data actually annotated in quite detail with what's on the images, which we'll also be releasing to the public and everybody here, in order to be able to train these models and actually make them work really well. Because you can imagine the city is a very visually, heterogeneous place, as we call it. So it's always very different, so you need a lot of examples for it to work good. But now we got to a large enough data set for it to actually work well. So if you want more information about this, there's a paper about it, and there's a few websites, so please feel free to check it out. And this is, well, a topic we really have to discuss, I think, as well, when we're talking about putting cameras everywhere. It's quite essential that we have a little talk about privacy. So what I think the nice thing is with using computer vision is you can actually turn this camera basically into a sensor. You can process the image and you don't have to store it. So that's what I mean with the point only doing inference. And the idea is that we can basically process the images without saving them. Eventually, we can also process them in the phones, because those are also getting much stronger with processing power. So you would actually be making it much more privacy friendly. And at the same time, for example, we remove images we don't need. And you might have seen it in the example before. We also blur away people and license plates because we don't need that information. So this is an example. This is one of the images from the high resolution panoramic car. The resolution is higher than you see here, where we just blur away people. So we can actually publish this data publicly without people being spotted on it and losing their sense of privacy. And this is a project of an intern we have. Every year we have 20, 25 data science and AI interns working with us doing like small research projects. We figured, well, we can turn my face into Tom Cruise. So can't we like anonymize people like this? Can't we take the picture and remove people from it, but then generate, well, synthetic people that do not exist? So this is actually, well, I'm not sure if you could see which one is the fake, which one is the real, but I would say it's already getting pretty good. So 50% of these images, the people are not actually existing. They were never there at that moment. So I think it's also always interesting for legal people to think about, does a synthetic person have a right to privacy, or even like any rights? But there's also, I would say, a risk to it. Imagine being generated somewhere. That would be even worse than being spotted at a place where you were. Imagine being generated in front of the house of your ex-girlfriend. That would be also very interesting and, well, unlikely to happen, but I think unlikely things can also happen. So that's a quite interesting thing. I think we'll have some debate in the next years. And it's like a different solution. So I mentioned before, like on an image you can count a dog. Well, you can also use this type of technology to count people on a large scale. So normally you have like object trackers where you, for example, count bicycles or people passing a certain point that are normally actually a bit more like the image here, so pretty close to the street. So what we actually were developing to count crowds in the city at a larger scale around football stadiums or at Dam Square, we had a camera really high up, and at first we called it Eagle Eye. We changed it to Public Eye because we want everything to be public. It's a system that can count crowds on these images very accurately. So that's very useful, for example, when there's a demonstration, we can quickly count the amount of people there. So this uses like density maps to see how dense the crowd is at a certain point, and you can count very accurately. So the example here shows 114. This is from an academic data set, because we don't want to show the images of the demonstrations. But it can count like numbers of 2,203 people very accurately. So it's very useful and very nice technology. And what we, for example, use it for in the marineterrein, it's like a, recreational area in Amsterdam. We have a few of these cameras, and there are screens everywhere. So when people walk into this area, it's an old Navy place, so they have gates, but it's now open to the public. People can, at the entrance, will see, okay, maybe in the front, the park is very busy, but in the back, there's still a lot of space. We also have a website called druktebeeld.amsterdam.nl, which actually gives an overview for the whole city, like for all parks, like how many people are there at that moment, which we made during COVID because we hoped people would check it out, and when they decide where to sit in the sun, they would actually go to a place with less people, because I think people like that, especially during COVID. And then we can actually make sure that we can distribute the use of the city in a more equal way, and everybody can enjoy it more. And the nice thing with this is also the system doesn't need to save the images. So it will just be outputting the amount of people on the location, for example, on Dam Square, every minute or every few seconds. So it's also much easier to process eventually into dashboards instead of images. And this is the last one I want to discuss for today. So this, what you see here is a point cloud scan of the whole city. So this one is rendered, I think, in Unity. So we have these type of tiles now for the whole city, which I think is very interesting data to work with. However, I think for Amsterdam it was about 6 terabytes of points. So you have a color and an X, Y, Z value. Well, I think not every analyst would be able to load that on their laptop on whatever machine. So we were looking for a way to reduce this information into something that's very useful. So what we did here, of course, first combine it with the open data of the city. We could use height information to remove the grounds. 50% of the points, I think, 50% of the points are grounds, so that's not very useful information. We could also easily remove the buildings like that without having to need for examples of what is buildings. And then for some of the objects that are remaining, we labeled a few of these tells, as you call them, and then trained the model to be able to segment them out of the image. So the nice thing is, for example, you can see here the light post, we can position them very accurately. And that's useful because it will allow us to increase the quality of the data to know where these are. And you might think, why is that so important? But if you make a report of a broken street light and it's linked to the wrong one, we will send a contractor there to fix it, and they will say it's not broken. So, and that will cost a few €100 every time. And if you have 125,000 light posts, then eventually that's like quite a sum of money when the data is not clear. So I think like the point clouds is one example how they can be used, but I think they can be used for a lot of different things. For example, the height of the curb to see, is it accessible for a wheelchair in what areas and what areas not. So it's actually limitless what you can do with it. So this system is also, we're developing it open source. So if you manage to scan a point cloud of the city or buy one, you can use our system, hopefully as well, with some adaptations to actually extract the information from it. As I said, like I couldn't mention everything in this presentation today, but there's more of it on our website, amsterdamintelligence.com, where we have a weekly blog with the projects that we're working on. So really encourage you to check that out. So there's the ones I discussed today are on there, and also the new projects that we're starting will be documented here. And yeah, that's it for today. So thank you for your attention, and enjoy the conference.